Good day, everyone. So, continuing our topic for the subject solid mensuration, our topic is about the properties of regular polygons. So, before we proceed with the properties of regular polygons, we can discuss first about the similar polygons. So, similar polygons, we will be talking about ratio and proportion. So, the ratio of two quantities is the quotient of one quantity divided by another quantity. So note, however, that two quantities must have same kind. So proportion is an expression of equality between two ratios. That is, if two ratios A and B and C and D are equal, then the equation of the two ratios A and B and C and D is a proportion. Thus, you can say that A and B are proportional to C and D. Two polygons are similar if their corresponding interior angles are congruent, as shown in the given figure here. So the interior angles should be congruent and all of their corresponding sides are proportional. So similar polygons have the same shape but may differ in size. So on this, considering the given similar polygons, the following relations between the two polygons are obtained using the concept of ratio and proportion. So first of which is the ratio of any two corresponding sides of a similar polygons are equal. So this refers to the given uh, sides of the similar polygons. So the two corresponding sides. Okay, so let's say x1 and x2 and y1 together with y2. So the given formula or equation is the ratio of the x side will be equal to the ratio of the uh, y side. Okay? The ratio of the areas of similar polygons is the square of the ratio of any two corresponding sides. So when we talk about area, so the ratio of the area, okay, will be equal to the square of the ratio of any two corresponding sides. So for this particular equation, the sides are squared. Okay, so you can use the y side, y1 and y2, these two, or you could simply use a1 all over a2 will be equal to x1 all over x2, then quantity squared. Okay, and the last one is the ratio of the perimeters of similar polygon is equal to the ratio of any two corresponding sides. So for the perimeter, okay, you could simply use uh, uh, the sides, okay, the ratio of any two corresponding sides, like for example ax1 x2 or y1 y2. So you could say perimeter 1 all over perimeter 2 will be equal to side y1, okay, and then all over side y2, okay. And take note that for the ratio of the area, the sides are in squared, okay. So the ratio of the square of the ratio of the sides, while the perimeter is simply the ratio of any two corresponding sides. Now let's talk about the properties of a regular polygon. So what are regular polygons? So regular polygon of n sides can be subdivided into n congruent triangles, okay, whose base is also side of a polygon, and the common vertex of these triangles is the center of the polygon. So to find the perimeter, okay, of a regular polygon, so add the lengths of the sides of the given polygon. So if this is a polygon with continuous sides here, you simply add all of those sides to get the perimeter. Since it is a regular polygon, so all sides are equal. So you can multiply the number of sides by the length of one side, as shown here. So where n, okay, is the number of sides, and S represents the length of each side, and P is the perimeter of a regular polygon. So you may want to uh, be familiar with this formula. The central angle. Okay, so the central angle is the opposite side of a regular polygon. Central angle theta of the polygon. So it is the angle formed by two lines drawn from the center of the polygon to the two adjacent vertices. So from the center of the given polygon, drawn connected to the two adjacent vertices. So vertex 1, let's say vertex 2. Similarly, if there's a vertex here, you could draw a line connected to that vertex, then the central angle will be given here. So for clarity, okay, I didn't draw the whole polygon. Instead, it has been drawn by a representation of a triangle for the given side of a polygon. So that this is the central angle itself. And the formula is given 360 degrees all over the number of sides of the given polygon. So the apothem. So the apothem is the altitude of the isosceles triangles that can be formed, okay, from a regular this polygon. So the apothem bisects the central angle, okay, to its opposite side. So this perpendicular line drawn from the vertex up to the uh, side, okay, is called the apothem. And then it bisects the central angle, so it divides it by 2, okay, and then the side is also divided by 2, okay. So the formula for the apothem is will be equivalent to S represents the length of the side all over 2 tangent, then 180 degrees all over number of sides. So hopefully you could memorize them, okay. And then let's talk about the angles. Okay, so the interior angle and the sum of interior angles. Okay, so for the interior angle, okay, you have this formula. So it's represented by IA. Okay, so that is the abbreviation for the interior angle. So the interior angle is equivalent to the product of the uh, number of sides minus 2, okay, and then multiplied by 180 degrees and divide the whole uh, product by the number of sides. Okay, so this is the formula for the interior angle. And for the sum of interior angles, so you simply multiply the interior angles by the number of sides. So for this particular one, if I'm going to multiply n, or the number of sides, so eliminated, n will be eliminated. So the formula for the sum of interior angles is 180 degrees multiplied by n minus 2. Okay? So hopefully you could memorize all of them. So area of regular polygon. So what is an area? So area is the amount of two-dimensional space that a plane figure occupies. So you can also calculate the area of a regular polygon by means of computing for the area of a single isosceles triangle formed, okay, in a regular polygon, and then multiply by that area or that value by the number of sides, okay. Or in terms of this one, the area of the given regular polygon is 1/2, okay, perimeter, okay, multiplied by apothem. So where perimeter is number of sides multiplied by the length of each side. So this can also be written as 1/2 NSA. Okay, so hopefully that is clear. Another formula, given sides and given number of sides, and it's what you call this length of one side. Okay, you can use this formula. Okay, either which depends on the given. So if the given is in terms of number of sides, apotem, and call this number of sides, apotem, and the length of one side, you can use this one or this one. Okay, so the area, another formula for the regular polygon is number of sides multiplied by the square of the length of each side, okay, divided by 4 tangent 180 degrees all over n. Okay. So diagonal. Okay, so you're familiar with diagonal. So the diagonal, okay, is a line drawn from one vertex to a non-adjacent vertex, as shown here. Okay, so the formula to be used in computing the diagonals of a regular polygon is this formula. Okay, so that is equivalent to n all over 2, then multiply it by n minus 3. Diagonal. Let's have some illustrative problems. So use the diagram below to answer the questions A to D. So A, is the polygon convex or concave? How many diagonals can be drawn from vertex A? How many sides does the polygon have, and what is the name of the given polygon? Okay. So for letter A, is the polygon convex or concave? So probably you should be familiar by now whether what are the definition of convex and concave. So when we say convex, okay, uh, the interior angle, okay, should be less than 180 degrees, while concave, okay, so at least one of the interior angle has an interior angle of more than 180 degrees. So less than 180, okay, and this one has an interior angle that is more than 180, okay. And then also if you draw line, okay, so for convex, at least two, okay, lines could be intersected, and for concave, okay, two or more, okay, or more than two. Yes, that is the rule for concave. So let's see first the interior angle. So probably this is less than 180, less than 180, less than 180, but this one, okay, this is more than 180 degrees. So there is one interior angle that is more than 180 degrees. Similarly, if I'm going to draw a line passing through here, two sides intersects, okay, and this one two side intersects, and probably if I'm going to draw a line here, okay, so 1 2 3 4 sides could be intersected by that line, okay. So intersects two or more sides. So therefore, the answer for question A, okay, is a concave polygon. So for letter B, how many diagonals can be drawn from vertex A? So when we say diagonal, okay, so from a vertex, that is a line drawn, okay, to a non-adjacent vertex. So this one, okay, this is a side, so it is connected to adjacent vertex, similar to this one. Non-adjacent should be connected from point A to a non-adjacent vertex, similarly to this one. So probably there are two diagonals that can be formed or drawn from vertex A. And how many sides does the polygon have? So you can count them. So probably 5 sides. And what is the name of the polygon? So the name of the polygon is a pentagon. Let's have problem number 2. So find the measure of an interior angle of a regular tridecagon. Okay. So first things first, when solving problems like this one, worded problems, first things first is that you need to understand what are the given. Okay, if you didn't understand the given or the possible unknown, kindly read the problem twice or even thrice. So for this particular problem, find the measure of an interior angle of a regular tridecagon. So the given is a tridecagon, which is has how many sides? Okay, tridecagon. Okay, so you should be familiar with that one. Then the required is, based from this one, find the measure of an interior angle. Okay, so the known or the required is an interior angle. Now, for the solution, let's go with tridecagon. How many sides? So the regular polygon is a tridecagon, which has a 13 sides, or this can also be called 13-sided polygon. So the formula for the interior angle is given 180 degrees multiplied by the difference between n and a number of sides and 2, and then all over or divided by the number of sides. So the number of sides is given as 13. We may substitute this value to the given equation. So 180 degrees and then 13 minus 2, and the denominator is 13. Using your calculator, you can compute that. So the interior angle of the given tridecagon is 152.31 degrees. The problem 3. What is the sum of the interior angles of a regular icosagon? Okay, so what are the given and what are the required? Okay, so the given is an icosagon, or I mean a regular icosagon. Then the required, based on the given problem, so the sum of interior angles, so SIA, a sum of interior angles. Now, for the solution, you need to determine first the number of sides of a regular icosagon. So an icosagon has 20 sides, or a 20-sided polygon. So using the formula of the sum of interior angles, okay, so 180 degrees multiplied by number of sides minus 2. So we can now substitute the number of sides, which is 20, to the given equation. This gives us 180 degrees multiplied by 20 minus 2, and simplifying that using your calculator, you'll get an answer of 3240 degrees for the sum of interior angle of a regular icosagon. Problem 4. The number of diagonals of a regular polygon is 35. Find the area of the polygon if its apothem measures 10 centimeters. So if you didn't get what are the given and the unknown or the required, you may need to read the problems one more time. So the given are, the number of diagonals of a regular polygon is 35. Okay, so find the area, okay, of the polygon if its apothem measures 10 centimeter. So those are the given values. Now the required is the area. So find the area of the polygon. Solution. Okay, so before you proceed with the solution, you have provided the given and the area, or the unknown. Okay, so based on the given, you should come up with the formula. You are given a diagonal, or the number of diagonals. From the properties of a regular polygon, you have a formula for this one, for the diagonal. And similarly with apothem, you have a formula. Okay, so then let us use the given diagonal with given 35. Okay, so using the formula of diagonal, okay, so from this given, okay, you are given the value of the diagonal, and there are unknown here, so probably n, so they are similar. So you can determine the number of sides of a regular polygon. So substituting the value of 35 to the value of d could be 35 will be equal to n all over 2 and n minus 3. Simplifying the given equation, you'll get this new equation. So you could multiply both sides by 1/2. Okay, so 1/2 multiplied by n all over, I mean 2 on both sides in order for you to eliminate 1/2 here. So 2 multiplied by n all over 2, that gives us 2 divided by 2, 1. So n minus 3, this one. And then 2 multiplied by 35. So simplifying the given equation, you'll get this simplified equation here. But then the given equation is in second degree polynomial. Okay, so you would need to determine the value of n in solving quadratic equation, okay, or second degree polynomial based on your algebra. You could use different formulas like quadratic equation or factoring probably. Okay, so for this particular problem, okay, I'll be using factoring. Okay, so the factor of this given equation is n minus 10 and n plus 7. Okay, so from these two factors, you will be equating them, okay, or each one of them to 0. So that is n minus 10 will be equal to 0 and n plus 7 will be equal to 0. So for n minus 10 will be equal to 0, to solve for n that is equivalent to 10. And the other one, n plus 7 equals 0. So this gives us n will be equal to negative 7. Take note, for the number of sides, there are no negative value for the number of sides. So we always take the positive value. So the number of sides of the given regular polygon is 10. Now we can use that in order to solve for what? Based on this given formula, what are we going to solve? You have given a, which is apotem. You are given the number of sides. So we can now solve for the length of each side of the given polygon. Okay. Substitute the given values. Apotem is 10 centimeters. The number of sides at the denominator is equivalent to 10. And you can simplify this equation to solve for the length of the side. Simplifying, you'll get this equation. 10 multiplied by 2, then multiply by tangent 180 all over 10. Then using your calculator, you could get the length of each side is 6.5 centimeters. Now the required is area. Okay, so recall the formula for area. We have two formula, which is 1/2 perimeter and apotem, or you could use this one, which is n, the square of the length of one side, for tangent 180 all over n. For this particular problem, I will be using this formula. Okay, so 1/2 perimeter and apotem. So 1/2 PA, and you know perimeter, okay, is the product of number of side and one of length of one of the side of a polygon. So 1/2 NSA. So NS is equivalent to perimeter. Okay, so substituting value, you have N, which is 10, number of side, length of one side, which is 6.5, and then the apotem, which is 10 centimeters. Okay. So simplifying this using your calculator, you'll get an answer of 325 square centimeter. Next problem. Problem number 5. So the measure of an interior angle of a regular polygon is 144 degrees. Find the apothem if one side of the polygon measures 5 units. So again, first things first, you provide the given. So the given is an interior angle, okay, which is 144 degrees, and the length of one side, which is 5 units. And the required, the apothem. So find the apothem, okay, the given regular polygon. Okay, so you have the formula for apothem, which is this one, length of one side, which is given, and then 2 tangent 180 degrees all over n. So we don't have n, or the number of sides, and we don't know the name of the regular polygon. Okay. So using the formula for given here, which among those two given has a formula? Of course, the interior angle. Okay. So the solution, using the formula for the interior angle, based on the given of 144 degrees, you have this formula. So 180 degrees multiplied by n minus 2, then divided by the number of sides. So substituting the value of 144, okay, then simplifying the given equation, okay, so multiply both sides by n, gives us 144 degrees n, and then 180 degrees n, and 360 degrees. So the numerator, or the 180 degrees here, is distributed. Okay. Then combining like terms, you could subtract 144 and add 360 on both sides. So that gives us this one. Okay. So 180 degrees n minus 144 degrees n will be equal to 360. Simplifying that one, that gives us 36 degrees and equals 360 degrees. So dividing both sides by 36 degrees, the number of sides is given as 10. Now using the formula for apothem, you have now the length of the one side, which is 5 units, and the number of sides as 10. Substituting those values in order to solve for the apothem, you'll have this equation. So 5 all over 2 tangent 180 degrees all over 10. And the length of the apothem, okay, is given as 7.69 units. Problem 6. So find the number of sides of each of the two polygons if the total number of sides of the polygons is 13. And the sum of the number of diagonals of the polygons is 25. Again, if you didn't quite understand the problem, you may need to read it again. Okay? So based on the given, okay, so probably total number of sides is 13, and the total diagonals of the two polygons is 25. So probably let us provide some indications for those given. So I will be let, so n1, the number of sides of the first polygon, and n2, the number of sides of the second polygon. Take note, there are two polygons, okay, or two unknown regular polygons in the given. So the total number of sides, so you have polygon 1 and polygon 2. Okay, that's why I indicated n1 for the first polygon, that is the number of sides, and n2 for the number of sides of the second polygon. Similarly, you have the sum of diagonals of the given polygon. So therefore, I'll just assign the number of diagonals of each polygon by let's say D1 as the number of diagonals of the first polygon, and D2 as the number of diagonals for the second polygon. Okay, so, and then the required are find the number of sides, okay, of each of the two polygons, determining n1 and n2. Okay, so probably possible solution. First, you need to gather data from the problem. So the total number of sides, let's take that one. So the total number of sides of the polygons is 13. Therefore, in equation, you have n1 plus n2, okay, will be equal to 13. Similarly, the sum of the number of diagonals. The sum of number of diagonals of the polygons is 25. So you have an equation of d1 plus d2 is equivalent to 25. Okay, let's call this equation 1. Okay, so n1 plus n2 lower will be equal to 13. Let's call this equation 1. And d1 plus d2 equals 25. Let's call this as equation 2. So we have two equations based on the given problem. Now continuation. So we have determined these two equations. Okay, so I'll just use the first equation. Okay, so from equation 1, you have n1 plus n2 equals 13. Okay, you can derive an equation in order to solve for n1, and that gives us this equation. Okay, n1 is equivalent to 13 minus n2. Okay, let's call this equation as 1.1. It is based from equation 1. Okay, now using equation 2, this one, d1 plus d2 equals 25, we substitute the formula of the diagonal. So recall your formula for the diagonal as this formula. Okay, so if I have a subscript of 1, okay, then this should be 1 and 1. If that is 2, diagonal 2 for side 2, a number of side for the second polygon. So let's have a substitution. Oops. So this gives us n1 all over 2, which is this one for d1, then n1 minus 3, okay, for d1, plus d2. So n2 all over 2, then n2 minus 3, which is equivalent to 25. So hopefully that gives us clear view now. Okay, now moving forward, okay, simplifying the given equations. Okay, uh, this can be multiplied, shown here. So n1 squared minus 3n, then denominator of 2, plus n2 squared, then minus 3n2 all over 2 will be still be equal to 25. Okay, then multiplying both sides by 2 probably. Okay, so this the denominator of 2 can be factored out, then 1/2 multiplied by 2 will be equal to 1, and this one 2 times 25 is 50. So this gives us now n1 squared minus 3n1 plus n2 squared minus 3n2 will be equal to 50. Now from this particular equation, okay, so let's call this equation 3. Now continuing, okay, you have here the equation 3, okay, and the previous equations. So using equation 3, continuing, we substitute the value of n1, which is equation 1.1 from this equation. So let us use equation 3, then change n1 to 13 minus n2. Okay, these two here. So that gives us 13 minus n2, which is n1, then squared. so it should be squared. Then 3 by minus 3, n1, 13 minus n2. Then plus n2 squared minus 3n2 equals 50. Now simplifying these terms, okay, so 13 minus n2 squared, then negative or minus 3, 13 minus n2, we'll get an equation of 169 minus 26 n2 plus n2 squared minus, okay, 39, okay, and then plus 3n2. Okay, by the way, this one, if you use FOIL, okay, so you get this equation. 169 minus 26 n2 plus n2 squared, okay, for this particular term. Then minus 3, okay, so it's distributed, so negative 39 and positive 3n2. Then plus n2 squared, and then minus 3n2 equals 50. Combining like terms, n2 squared, n2 squared, both are positive, so you get 2n2 squared. And then negative 3n2, positive 3n2, they will be eliminated. And then you'll get negative 26n2. And 169 minus 39 minus 50. So by simplifying, you'll get this equation. Okay, so 2n2 squared minus 26n2 plus 80 equals 0. Again, this is in quadratic equation or second-degree polynomial. But then look at the variables or the constant, okay, or the constant. This can be simplified by multiplying 1/2. Okay, so on both sides, so you'll get a new equation or a simplified equation of that given is this one. So n2 squared minus 13n2 plus 40. Okay, so from this equation, okay, second-degree polynomial or quadratic equation, you can use quadratic formula or factoring. Okay, so I'll just use factoring. So I have factored it to n2 minus 8 and n2 minus 5. Okay, so if you're going to use FOIL method for this one, we should have an answer equal to this given. Okay, again, similar procedure from the previous problem. Each factor will be equal to 0. So n2 is equivalent to 8, and this one is 5. Both are positive and can be considered. Okay, so let's use equation 1, okay, or 1.1, determining for n1. Okay, so if my answer is negative for n1, okay, that value for n2 will be eliminated. Otherwise, if positive, it could be accepted. So let us use equation 1.1. Then we get n1 is equivalent to 13 minus n2. So let us consider 8. So 13 minus 8, that gives us 5. Similarly, okay, if you're going to use 5, 13 minus 5, you'll get 8. So therefore, the possible answer for the number of sides of each of the two polygons is 5 and 8. Problem 7. What is the name of a regular polygon with 90 diagonals? So the name of a regular polygon is unknown. Okay? And then you have given of 90 diagonals. And the required name of the regular polygon. So your possible solution, you need to use the given itself. Based on the given, you have possible formula in mind. So for this particular given, diagonal. So you have a formula for diagonal. Then you can determine the number of sides. Okay? Substituting the value of the diagonals, which is 90. Okay? And then simplifying this one, multiply both sides by 2 and get 180 equals n to n squared, and 3n. Then simplifying that equation gives us a second degree polynomial. Okay. So again, for second degree polynomial or a quadratic equation, you can use quadratic formula or factoring if it's applicable. So I'll be using factoring n minus 15 and n plus 12. Okay, so based on the given, each of the factor will be equated to 0. So n minus 15 equals 0 and n plus 12 equals to 0. So n will be equal to 15 for this factor, and for the second one, n will be equal to negative 12. So we don't have negative sides, okay? So make sure you select the positive value for the sides. So therefore that is a 15 side polygon, okay? And the name of the polygon will be pentakai-decagon. So find the area of a regular nonagon for problem number 8, whose sides measures 3 millimeters. Determine the number of distinct diagonals that can be drawn from each vertex and the sum of interior angles. So what are the given? A regular nonagon, which has 9 sides, and the measure of each side is 3 millimeters. So a nonagon has 9 sides, okay? And the given for the length of one side is 3 millimeters. The unknown or the required is determine the distinct number of diagonals, or first is the area. Okay, so find the area of a regular polygon. Then the distinct diagonals, and the sum of interior angles. So let's solve first for the, let's say, area. Okay, so you have this formula based on the given. Okay, you could use this formula. The other one, which is 1/2 PA, we don't have a value for apotem, so we cannot use that one. Or you could use that 1/2 PA or 1/2 NSA if the apotem, side, or length of side and the number of sides are given. So for this, in this case, we only have two givens, which is n, or the number of side, and the length of one side. So substituting those values, we'll get 9 for the number of sides, and length of one side is 3, which is squared. Then the denominator, 4 tangent 180 degrees all over 9. Simplifying that using your calculator, you'll get an area of 55.64 square millimeters. Now for the diagonals, you have the formula for diagonal, which is n all over 2 and minus 3. You are given number of sides, so therefore you need to substitute that value to the given formula and simplify that using your calculator. So the number of distinct diagonals for a regular nonagon is 27. And lastly, the sum of interior angles. And you have the formula for sum of interior angles, which is 180 degrees multiplied by n minus 2. You have n, which is 9. Substitute that value and simplify that with a given. Okay? Using your calculator, you'll have a sum of interior angles of 1260 degrees. So the answers to the problems are 55.64 square millimeters for the area, 27 for the diagonals, and 1260 for the sum of interior angles. Problem 9. One side of a polygon measures 10 units. If the measure of the corresponding side of a similar polygon is 6 units, find the ratio of their areas. Okay. So what is the area of the larger polygon if the area of the smaller polygon is 12 square units? So probably the ratio of their areas, okay, so I'll just say this one. So the given, right, are 10 and then 6, and area of 2 and area of 1, which is area of 2, right, is given for the second question. So what is the area of the larger polygon? So probably, okay, so the ratio of their areas, okay, so you'll have A1 L over A2, okay, and that is equal to the square of the two corresponding sides. So you could solve that one, okay. So probably 10 square all over 36, okay. Simplified that one, probably that is the answer. So for the first question here, okay, find the ratio of their areas. So the ratio of their areas is 100 all over 36. So area A1 all over A2 is equivalent to 100 over 36. And for the second question, what is the area of the larger polygon if the area of the smaller polygon is 12 square units? So the ratio of the area, okay, is given as this one. So if A2 is 12, okay, and this one is the given, so Y1 is 10 and Y2 is 6, and area 1 is unknown, and area 2 is given as 12, okay. So simplifying that equation, you'll get 12 multiplied by the square of 10 all over 6, okay. Simplifying that using your calculator, you have uh, 33.33 square units. So that is for the second question. The answer for the first question, find the ratio of their areas. So the ratio of their area is A1 all over A2 is equivalent to 100 over 36. So that's it. That's all for the polygons. Okay. So our next topic will be all about triangles.